Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mask code at this side. So let us continue the series of binary tree. Right, we have made many lectures up till now. I guess this is lecture number 14. So now the question is, I'm actually escalating a level up. Up till now, we were solving easy questions. We were actually clearing our concepts, right? We were clearing our concepts. Now let us move towards the medium type of the question so that we actually cover a variety of questions. Now the problem is construct binary tree from pre-order and in order. That is, previously what you were doing is you were given a binary tree and you were giving me these two traversals, right? You were giving me these two traversals. But now the problem has reversed itself. You are given with the traversals, two traversals are given to you. You have to return me the binary tree. You have to return me the binary tree that on pre-order gives me this order and on in-order gives me this order. Now, whenever you see a question, no matter of which topic, it can be a binary, linked list, tag, queue, etc., anything, your first thing should be what is the algorithm. You should be worried about the algorithm because a true coder only requires the algorithm. He should be sufficient enough to convert this algorithm into code, right? Code is the simplest thing you can do. Algorithm is somewhat you have to apply your mind. Okay. Now, what can be the algorithm? So let us start by doing how can we do it in real life? How can we do it in real life? So you should be clear with the definitions of pre-order and in-order, already explained in the playlist. What is pre-order traversal? Pre-order traversal is explore the route, go towards the left, and then towards the right. Am I right? Pehले explore the route, then go towards the left, then go towards the right. What is in order? In order is go towards the left, then explore the route, and then explore the right. That is, go towards the left subtree, explore it, then come towards the root, and then at last go towards the right subtree. Okay. Now, if I try to explore about pre-order, it says explore root at first. Explore root at first. So, can I say the first element of the pre-order traversal, that is 3 here, is the root of the entire subtree? Is the root of the entire subtree. You can see that you can make any tree you want. Suppose your tree looks something like this, right? You can see what was our technique to get the pre-order traversal. We just put dash on the left side of it and we just run something like this, the line something like this, right? Now, as you can see, the first intersection is always going to be at root. So, the first value of the pre-order traversal is always going to be the root value. So, I can clearly say that 3 is my root. I don't know about the other elements right now, but 3 is my root. I am sure about that. Okay, 3 is my root. Now, it will have some elements on the left, it will have some elements on the right. We have to figure out what are the elements on the left subtree, what are the elements on the right subtree, correct? Now from 3 I can say, let's do one thing, let's locate 3 on in order. So 3 is lying here on in order traversal, 3 is lying here on the in order traversal, no problem. If 3 is lying here and 3 is my root, 3 is my root. In-order traversal says on the left of the side of the root, left subtree lies. On the right side of the root, right subtree lies. So, if I try to apply my mind, isn't this part the right subtree and isn't this part the left subtree? What I am saying is, if 3 is my root and towards the left is my left subtree, towards my right is my right subtree, that means 9 is the only part of my left subtree, whereas 15, 27 are my, what do we say, the right subtree, right? So let us write it down. That is, we configured up till now that 9 will come here, 1527 will come here, 1527 will come here, and you can see that because the pre-order has left and then right, that means 9 is coming here and 1527 are coming in a group after 9. They are coming after 9. You can see they are coming after 9. 9 is not between them. 9 is prior to them. Okay. Moving on. What can I say? 9 is here. 9 is the only element. That means it is the only node in the left subtree of 3. Right. But we have to figure about these 3 elements. Like what is the root here and what are the children, etc. etc. Right. So how can we do that? Again, we will look at the pre-order traversal. Now, as I said, this is the right subtree, this is the right subtree. It will always be the case in the case of pre-order in order, the 3 elements will actually be together. The left subtree will actually be together. Like if there were 2 elements here, then there were 2 elements, then 2 elements here. The first 2 elements would have been same. What I'm saying is n elements here and n elements here would be same. They are actually of the left subtree. And x elements here are actually equals to x elements. The value should be same. 20, 15, 7, 15, 27. You can see the elements are same. Just they are jumbled up. right? 20, 15, 7. Can I say for this subtree, if this I treat this right subtree as a simple tree, can I say because of this pre-order 20 is the root again? Can I say 20 is the root again? Yes, I can say I'm using the same logic from which I got the 3 value. I'm using the same logic to get the 20 value. I will do that. So this tree is now more defined up till 3 with 9 with 20. Now, I will find 20 again in the in-order traversal. I will find 20 again in the in-order traversal. Again, in this particular portion, 15 is on the left part, 7 is on the right part. That means 15 is the left subtree, 7 is the right subtree, and I will get my tree something like this. 15 in the left version and 7 in the right version. And you can see that this tree will actually give me the same pre-order and in order, and this is the only unique tree. This is the only unique, please focus, this is a unique tree that can be made, which gives me the exact pre-order traversal and the exact in order traversal. You can check it too, right? It's your task to check it. I'm not going to traverse it again and again, right? Okay, so this is my binary tree. What was our algorithm? We just figured out the algorithm. Our algorithm was something like this. Correct me if I'm wrong. First value of preorder equals to root of tree, equals to root of tree. After that, find the value in order, find the value in order, right? Elements, or I can say number of elements in left part of in order, in left of root in order traversal, in order traversal are belonging to the left subtree, of the root of this root, and number of elements in right of root in order traversal are belonging to the right subtree. So these are the three steps you have to do to get the tree out of your given pre-order and in order. So if I try to move to this approach again, that is this sub arrays, and I try to configure how I am going to deal with the indexes here, that will be much easier for you, for me, because I know about that what is the main approach, right? So our pre-order is 3, 9, 20, 15, 7, and our in order is 9, 3, 15, 27. 9, 3, 15, 27. This is my pre-order. This is my in order. Now, there are two approaches. Whenever I want to make an tree, I can send the whole pre-order for that tree. That is what I'm saying is, when I was making this 3 as my node, you can see that all of the pre-order and all of the in order was my array to be considered. But when I was making 20 as my node, I was only dealing with these 3 elements. That is, I was only dealing with the last 3 elements. This array was my focus. This array is my focus in the 3 elements case. So there are two approaches now. What is the approach? That for a particular tree, I will send only those elements. Right? This is my main idea. But two ways to do that are actually make a new vector, and send that. That is, this vector will only contain 15, 27. The second approach is very much easier. What I'm saying is that, like what we did in merge sort, we deal with the pointers. That is, these two pointers are actually implementing that what is the range for the current traversal of the pre-order. That is, for the first node, I have to look at from this pointer to this pointer and this pointer to this pointer. And for the 20th node, I have to look from this pointer to this pointer. So I will be dealing with the case of pointers. Pointers. 2 has to space complexity. Like I have to optimize the space complexity as well, right? So that is why I'm using the pointers case. So what will I do? In the starting, let me mark the indexes. 0, 1, 2, 3, 4. Right? Suppose I call the function for f. It will have to determine a node, which is my actual root, right? I will send my pre-order, I will send my in-order, obviously. Now, pre-start, that is the starting point of the pre-order traversal for the current set, is 0 in the initial function, right? So it is pre-start, which is initialized by 0. It is n minus 1, which is equals to pre-end. initialized by n minus 1, which is currently 4. Similarly, in start, that is starting range for Inorder traversal, which is currently 0, and in end for n minus 1, 4 here, right? I guess that is clear to you, right? Now, our first thing we have to do is we have to check whether our pre-start is less than equals to pre-end, because our base case will be to return null when pre-start actually surpasses pre-end, So, if pre-start is greater than pre-end, that means I have to return null. There is no value left for the current subtree. Return null, right? Else, what will you do? Your root is gonna be 3. That is the pre-order of pre-start. Otherwise, create a new node. Tree node star root equals to new node of value 3. That is pre-order. That is a traversal giving to me, and pre-start is the index I want to fill the value in the node, right? This 3 will get created. Second thing, I have to find this index. I have to find this element in the Inorder. So what will I do? I will say index equals to minus 1 currently, traverse it. So for I going from in start up till in end, what will you do? You will find this index. So if index, like if in order of I equals to pre-order of pre-start what will you do? You will say index equals to I, and I am free to break, right? This for loop has only this work, right? I will get the index. What is the index here? It is 1, right? I will get the index. Now the elements on the left of it, in start was starting from here, in end is here. Elements on the left, how many elements in the left subtree? Only 1. 0 1 0 1. How many elements on the left? So you can say that I end minus in start, that is left subtree has I minus in start elements, and similarly right subtree has 1 2 3, and the index is 4 here, that is 4 minus 1, that is right subtree has in end, this is index, oh sorry, just wait a minute, it is index minus in start, not I, it is index minus in start, right? Okay. And similarly in end minus index, right? So one element here, 3 element will here, left contains 1, right contains 3. Okay. Why I'm marking the left and the right? Because I have to define the pre-order, like pre-start and pre-end for the recursive function I'm going to call, right? So what will I do? So I know that I have index equals to 1. I want to reach here, that is pre-start plus left elements, right? Left is containing 1. So what will I say? So root left, that is left subtree of the current root we made, the new node we made, is gonna be f. What is f? The function we are defining. The left subtree will start from pre-start plus 1. You can see the left subtree will start from pre-start plus 1. Left subtree is equals to starting from pre-start plus 1. This is a new pre-start. What is the pre-end? That is for left subtree, where will the pre-end stop? So you can see left subtree contains 1 element. I have to stop the element at this only. So pre-start plus left subtree elements, that is pre-start plus the left subtree elements we calculated here. Subtree, left subtree. Similarly, what is the in start and in end? So in start is gonna be the same. That is in start. But what is the in end? So you can see for in end, I have to start from 0. I have to go up till 0. No, that is not the case. I have to go up till index minus 1. So what will that be? That is index minus 1. That will be my in start. That will be my in end, right? This will give me the root left. Talking about the root right. So you can see I have 3 elements on the right side. I want to start from here. I want to end at here. Now this is actually my pre-end. I have to start from here. If the starting point is given, if I get the starting point correctly, I am obviously short with the pre-end. So you can see from 7, I am going 1, 2, 4 minus 2. The right subtree has 3 elements, that is I am going pre-end minus right subtree element, let us say it is R, plus 1, that is 4 minus 3 plus 1, which is equal to 4 minus 2, which is equal to 2. You will land exactly here. So root right is gonna be f of what is the starting point? So it is equals to index plus 1. Index plus 1 for the pre-order. The ending point for the pre-order is pre-end. Pre-end. Starting point for in order is in index plus 1. And the ending point for the in order is in end. Am I clear, guys? Am I clear? So you can see this will give me the recursion function of this will give me the left subtree. Recursion function here will give me the right subtree, and at last I can simply return root. Return root. The first iteration, that is this, when you are calling this first time, you will be sending 0 and minus 1, 0 and minus 1, and you will get the tree, the answer tree as your answer. The answer tree as your answer. Please try to understand that this is a very important topic. This is a very important topic. It is actually asked in OM many times of big companies, right? So please be clear about it. If you have any doubts, I am here to clear you. Please, you can mention in the comments also. I will surely get back to you, right? What was our order? What was our order? We just found the value of pre-order, right? We just found the value of pre-order. What was the first value of the root? That was the root. Okay, so what was our order? We just found that first value of the pre-order is gonna be the root of the tree. We have to find the index of the same element in the in order. The left elements are gonna be of the part of the left subtree from the in order point of view, and the right elements are gonna be the part of the right subtree. Right? How did we approach it? Made three here, and then just some index manipulation. Which is actually very easy if you just write the questions down. You write something down and do index manipulation. It is actually very easy. Yeah, without pen paper it might be tough, but with pen paper it is actually very easy, right? Okay, so this is our, what do we say, the pseudocode, and I hope this is clear to you. And let us move to the actual code now. Let us move to the actual code. Alright, so here is the coding section in front of you. Let us start with the code without wasting any time. Okay, so our first step is to call the new function which we are going to make. Let us call it a helper function. So return, what do we return? The helper function. We will send the pre-order as it is, right? It is pre-order, and we will send the in order as it is. So in order. Along with it, we will start the pre-start, which is equal to 0 right now. And let me take the size of it. So int10 equals to pre-order dot size, right? And I will send n minus 1 as a pre-end, and in start is also 0, and n minus 1 as my in end, right? Defining the helper function, returning tree node star helper. What will it do? It will take the vector int pre-order and vector in order as it is. So I'm just copying it down instead of writing again. With it, it is taking pre-start, pre-end, along with it in start and in end, right? It is int in end. Now, first case, if my pre-start has actually surpassed my pre-end, and those of you are thinking that why not in start and in end, you can use that also. That would also have been surpassed. You can use that as a condition also. So return null in that case, right? Because the node is null because pre-order and in order are not actually for that range. Moving on. If that is not the case, create a new node. That is tree node star. The current root is equals to new tree node. And what I'm going to choose the value, that is a pre-order, pre-start. Now I have to define the left and the right. For that, I want the index in the in order traversal. That is, int index is currently -1. Start traversing. So for int I, going from in start I less than equals to in end I plus plus. What will you do? If in order of I equals to pre-order of pre-start, in that case index let me take the curly braces way, index equals to I and break, and it will always break. Don't worry about that. You will always be able to find the value. That are the constraints, right? Otherwise the question is not correct if you're writing the code correct. Obviously you have got the index. Elements in the left subtree are, we defined it, right? Elements in the left subtree are which are equals to index minus in start, and similarly elements in the right subtree are in end minus index plus 1. We defined it, right? I don't think that you must be confused here. We actually did all the index manipulations by writing it down. Now I have to define the root left subtree and the root right subtree. So root left is gonna be the helper function for preorder, inorder. What is the pre-start? What is the pre-start? So I actually use the root value. I will go from pre-start plus 1. That is pre-start plus 1. Up till where I will go? I will go up till pre-start plus left subtree elements. Plus left subtree. Right? Okay, it is capital S here. Okay. Now, what is the in start? So in start is actually the same. But what is the in end? So in end is index minus 1. And similarly, the root right, as we discussed, is equals to helper function of preorder, just a minute, in order, with, now what is the pre-start for the right of it? What is the pre-start for the right of it? So we will be manipulating with pre-end minus right subtree plus 1, right? Now, what is the in start? What is the pre-end? Pre-end is actually the same. What is the in start? Now, in start is going to be index plus 1 and in end is going to be the same. At last, return the root. Return root. Let us try to compile and run it. I should run fine. It should not give any error, I guess. Oh, it is giving some error. What is the error? Let me see. Right, it is giving some error. Let me check. Oh, I found the mistake. It is not plus 1 here. As discussed, it is index in and minus index. It should run fine. Let us try it now. It is running fine for the sample test cases. Let's try it for the hidden test cases as well. Please run fine. Okay, it is getting accepted. So thank you for watching. Hope you liked it and hope you were able to understand it. So please, if you are new here, do not forget to subscribe and like the video, and please watch the full playlist so that your concepts are actually clear. Okay, thank you, and we'll meet in the next video.